Quadratic inequalities. A quadratic inequality is an inequality that can be written in the form ax squared plus bx plus c less than 0 for real numbers a, b, and c with a not equal to 0. Now the symbol less than can also be replaced with a greater than, a less than or equal to, or greater than equal to. Now, what are the steps of solving a quadratic inequality? Well, step 1, you want to solve the corresponding quadratic equation. Number 2, you're going to identify the intervals determined by the solutions of the equation. And number 3, you're going to use a test value from each interval to determine which intervals form the solution set. So let me go ahead and write an example. Okay, so let's say step number 1. All right, I'm going to give you an example here. Let's say we have x squared, okay, minus x minus 12. And I'm going to write this to be greater than 0. Okay, so this is the question, right? And so then step 1 technically is to then, and let me go ahead and rewrite this so that it doesn't have that 1 there, because this is our question. So let's put this in the correct order. So we want to have step 1. Okay, so step 1 meaning solve the corresponding quadratic equation, meaning that we need to factor this. So we have x squared minus x minus 12, okay, and then we're going to set this equal to 0 because we need to factor this equation. So when we factor this equation, okay, we're going to create our x. We got negative 12, and then we got negative 1 for the value of b. And we got to figure out what two numbers can we multiply to get negative 12. When we add them together, we're going to get negative 1. Well, that's going to be 3 and then negative 4. So when we factor this equation, we get x plus 3 times x minus 4, and that's equal to 0. And so now we're going to use the 0 property to solve for both of those x's. So we have x plus 3 equals 0, or x minus 4 equals 0. If we solve for x here, we get x equals negative 3. If we solve for x over here, we get x equals 4. So these are our testing our testing points. Okay, so these are testing points that we're going to put on a number line. Okay, so this is the first step. Now the second step is we want to draw, okay, our number line. Okay, so we're going to put a 0 here. Okay, and what we're going to do now is now point where the negative 3 is. So the negative 3 we're going to put over here, and then 4 we're going to put to the right of 0. And then we're going to draw a line up to then intersect each of those points. So what we're going to do is we're creating 3 regions. We have region 1, which are all the values that are less than negative 3 going all the way towards negative infinity. Okay. Then we have region 2, which is going to be in between negative 3 and 4. And then we're going to have region 3, which goes from 4 all the way to positive infinity. So now we're going to identify these intervals. So since this says greater than, okay, and it doesn't have a line underneath it, that means that this here, and I'm going to use a different color here, that means that we have this interval that goes from here to negative infinity. So this interval number 1 is going to be negative infinity to negative 3. Okay, and then region number 2 is going to be between negative 3 and 4. And then region number 3 is going to go from 4 to positive infinity. Okay, so now we've done step 1 by solving the quadratic equation to find the testing points. And then number 2, what we've done is identify the intervals determined by the solutions of the equation. Okay, now in step number 3, they're asking us now to then use a test value from each interval to determine which intervals form the solution set. Okay, so what does that mean? Okay, that means if we look at region 1, okay, in region 1, there are values that go from -3 all the way to -infinity. So we're going to just pick one point from there. And that point, we're going to say x equals, well, to the left of -3 is going to be -4. And then we got to plug it into the original inequality. And that original inequality is the question that was given, which is x squared minus x minus 12. And we want to see if it's greater than 0. So what we're going to do is we're going to plug that value in for x and determine whether it's greater than 0. So we take -4 squared minus a -4 minus 12, and we're going to see if it's greater than 0. So -4 squared is positive 16. This is a negative times a negative, which is plus 4, and then minus 12. Okay, so 16 plus 4 is going to give us 20, and 20 minus 12 gives us what? 20 minus 12 gives us 8, and so therefore it is true when we test a value in region 1. So I'm going to put true in here for region number 1. Okay, now let's take a look at region number 2. Okay, so for region number 2, we're going to pick a value in that region. The easiest one that we can pick is 0, so let's go ahead and put 0 in there. And then we're going to go ahead and use the same inequality. So we have x squared minus x minus 12. We want to see if it's greater than 0. So we have 0 squared minus 0 minus 12. I want to see if that's greater than 0. Well, this is 0 and that's 0. And is -12 greater than 0? Well, that's false. So therefore, region 2 gives us a false situation. Okay, now let's take a look at region number 3. Region number 3, we can pick a value that's above 4, so we'll pick 5. And then again, we're going to plug it into the inequality x squared minus x minus 12 and to see if that's greater than 0. So we got 5 squared minus 5 minus 12. So 5 squared is 25 minus 5 is 20, and 20 minus 12 gives us 8 again, and 8 is greater than 0, so it's true. So that means it is true for that region. So how do we answer this? Well, I'm going to write this in step number 4 over here. Well, the solution is basically asking this. For what intervals, because it's saying use the test value from each interval to determine which intervals form the solution set, meaning that what makes it true where it's greater than 0. And those two are the ones that were true, which are these two. So we would say that the solution is -infinity to -3 union 4 to infinity, because that's where it's true. Now, let's take a look at what the graph would look like if we would graph this. Okay, so I'm going to go ahead and put this in a graph. So I'm going to go ahead and put our x squared here. All right. So we have x squared minus x minus 12, right? Now, so here is the parabola, right? And so we want to figure out where is this quadratic equation above 0. So if you notice here, okay, the x-axis tells us whether we're above the axis, where we're greater than, and then below the axis is where it'd be less than. So if you notice, it's above the x-axis until it hits this point, and it's below, below, and it comes back up, and then it's above the axis from here. So what it's telling us is that anything less than is greater than 0, and anything to the right is greater than 0. Now, if I put in this greater than 0, you're going to see that it's showing you where the parabola, so anything from here to -infinity and everything from here to the right is also above the x-axis. So that's what's telling us how it is. So basically we're saying anything that's below, and I'm going to go ahead and copy this graph so you can see what I'm referring to here. Okay, so this graph is representing this particular interval right here. Okay, so what it's saying here is that it's above at the x-axis from here all the way to negative infinity, and that point here is 3, 0. Okay, and then it is below the x-axis between 3, 0 and 4, 0. And then it's above from 4 to positive infinity. And so that's what it was asking. Now, if we change this question and said, okay, well, we wanted to find out where is x squared minus x minus 12 less than 0, well, then it would be this interval. And that answer would just be from -3, I'm sorry, that should be -3 to 4. Okay.